Hello everyone, we're going to talk about the area for a cone. Not area, surface area. So again, surface area is the area all the way around a shape, and a cone is built off of a circle. So to find the surface area, we first want the area of the base, and the base is just the circle. So your surface area to begin with is pi r squared, because that's the area of the circle. We're going to add to that pi times the radius times this new value L. And L is standing for the slant height, which is just meaning the height that goes along the left-hand side or right-hand side of your cone. And it's the height that is slanted, so not your altitude. It's called your slant height because it's the one that's leaning in. So it's essentially the hypotenuse of the right triangle that you see there. Okay. For volume, we have a formula 1/3 times pi times your radius squared. So there you see your formula for area of a circle. And you're going to multiply that by the actual height, which is your altitude height. Okay, so two different kinds of heights when you're dealing with three-dimensional figures, a slant height and an altitude or a regular height. So let's say that our slant height is 13 and my radius is 5, and I want to find my surface area. So for my surface area, it's going to be pi times the radius squared, so pi times 5 squared, plus pi times my radius, 5, times the slant height, which is 13. So to calculate this, we have 5 squared times pi, so 25 pi. And then on the right, I have 5 times 13, or 65 pi, which gives me 90 pi. That would be my exact circumference, but you could also, not circumference, surface area, but you could also multiply those two things out as well. And this is units squared. For volume, we have 1/3 pi times the radius squared again, and we have to find that value for height. Well, if you notice, we've created a right triangle over here. And if we know one of the sides is 5 and one is 13, we can set up Pythagorean theorem. So 5 squared plus 12 squared, giving you the answer, plus x squared equals 13 squared. You may recognize this is a 5, 12, 13, which is why I just said that. But if you do it out, we have 25 plus x squared equals 169. And that gives me x squared equals 144. If you subtract, finally square rooting, your height is going to be equal to 12. So multiplying that all out, and if it helps you, you might want to do the whole numbers first. So 5 squared times 12, and then divide those by 3. So multiplying by 1/3 is the same as dividing everything by 3. So 5 squared times 12 times pi divided by 3, which would give me 100 pi units cubed. Or again, you could multiply that all out and get a decimal. So 314.5. So that's how to find surface area and volume for a cone. Alright, so next we have pyramids. Pyramids are similar to a cone, but rather than their base being a circle, their base is a rectangle or a square. And that would be for a rectangular pyramid. Okay. The base of a pyramid could be an alternate shape. It could be a triangle, but you would have to modify your formula if that were the case. So for surface area, we again want to find the area of the base we just talked about. So if I tell you this is a square pyramid, meaning all sides congruent, area of the base would just be the base times itself, or base squared. Right? Then we want to add to that all of our lateral areas. So since we had a square, we are going to have 4 of the same triangles because they're meeting up here at the vertex. So again, if this were a rectangle or a triangle, your formula would be modified slightly to reflect that we wouldn't have 4 different faces, we would only have 3, and some of them may be different sizes. But here we have 4 times the area of each face, which in this case is a triangle, so it's 1/2 the base times the height of each triangle. Oops, that doesn't look right. And remember, slant height we use is L. Slant height, if you just pick up the lateral face, is representing the height of each triangle that is leaned up to meet at the top, to meet at the vertex. So slant height becomes the actual height of each triangle. Okay, so that's my formula for surface area if we have a square pyramid. Again, if it's a rectangle, you won't have 4 of the same faces. You will have to calculate each area for each face and add them all together. Okay, for volume, we have 1/3 times the area of the base multiplied by the actual height. So that height that's like an altitude right in the center. So area of the base times the height. And if you want to be more simplistic with your surface area, for surface area you can say it's the area of the base plus the number of sides of the base, so we'll say n, times the area of each face. Okay, so that may help you sort of visualize what we're finding here. So we're going to stick with the same types of numbers that we had for the cone. If I say the base is 10, and that makes this portion inside 5, I know that my height could be 12 and my slant height could be 13 there. So calculating the surface area, we would have the area of our base, which is 10 by 10, so 100, plus, and then since all of our triangles are the same, we have to find the area for a triangle that has each piece is 5, and your height is 12. So 1/2 base is 10 times height is 12 gives me 120 divided by 2, or 60. So 4 times the area of each face, which is 60. So we end up with 100 plus 240, which equals 340 units squared. Now for volume, we have 1/3. Area of the base we just calculated is 60. Or sorry, not, oh, I'm taking that back. That's the area of a face. So not 60, but the area of our base is 100. And we're going to multiply that by the actual height, which would be 12. Oh, I messed this all up. Sorry, the slant height of your triangle should have been 13 instead of 12, which is going to change what we did here. So, my apologies. The slant height is 13, which is how to find the area of your triangle. So we have 1/2 times 10 times 13, or 5 times 13, which would make, in our formula, 65 rather than 60. And that will change the 240 as well to 60, giving me 360 units squared. So now when I do the volume, it's 1/3. Area of my base is 100, or 10 times 10, times the actual height. So the actual height here is 12, which is where I went wrong. I didn't use the slant height before. So this gives me 120 divided by 3, or sorry, 1200 divided by 3, which is 400 units cubed. Sorry for my mistakes.